Welcome back to another video, and in this video we're going to be continuing on with our series on making accessible apps using Apple platforms. And in this particular video we are going to be covering how we can create custom accessibility rotors in UIKit. Now, in the previous video we took a look at how we can create custom rotors in SwiftUI and just how easy it is to do it on that particular framework. However, in UIKit and in AppKit, frankly, it's a little bit more involved. Now, again, I mentioned I'm not going to show you AppKit because, frankly, not even I have been able to figure out how to do it. It's a little bit more complicated than UIKit, and there's honestly no good code samples, so I can't teach you what I don't know. So we're not going to do AppKit. I'm sorry. If you guys have any code samples for AppKit's custom rotors at all, leave them in the comments, please. I want this to be kind of a good learning experience for all of us. And if someone has code samples for custom accessibility rotors using AppKit, it'll help all of us. So let's go ahead and get started. What we have right now is in Xcode here. We have an iOS application. In this application, we have a UI navigation controller, and this UI navigation controller contains a view controller with a UI table view. And inside of this UI table view, there are a bunch of cells that represent a location. Now, these are the same locations as in our SwiftUI app, but when we select a UI table view cell, it doesn't do anything. It doesn't go and navigate to a map or anything like that, because I wanted to keep this relatively simple. But you could, if you wanted to, expand on this and include a map. So just keep that in mind. We're just going to use a rotor, though, inside of this UI table view to navigate between our various national parks and our various monuments. All right, so with that out of the way, I should also mention that the UI table view cells are a SwiftUI view, right? So it's not a traditional UI table view cell. We are using a UI table view cell subclass, but the content configuration is set to a UI hosting configuration with a SwiftUI view inside of it, kind of a more modern way of building a table view cell. All right, so inside of Xcode, I have a method called configure rotors, or configure custom rotors, and inside of here is where we are going to create our rotors. However, I do want to create a little utility function. This utility function is going to create a rotor based on a category. So we'll say private func create rotor category, and this is going to be of type location.category. Right? Now, inside of here, well, actually, before we do that, this needs to return a UI accessibility custom rotor. It's a very long class name, but UI accessibility custom rotor is the class that we use to create our own accessibility rotors for voiceover and whatever other technologies may use the rotor. All right, now inside here, we are going to create a new rotor. So we'll say let rotor equals UI accessibility rotor custom rotor. So UI accessibility custom rotor. We need to pass it a name, and this is going to be a string. However, this string has to be dependent on our category. So we'll say name category equals, let's say, national park, question mark. We'll say national parks. Otherwise, it will be monuments. And then we are going to have a closure. Now, this closure is going to have a weak reference to self. So we need to say weak self, like this. And then it's going to take in a predicate. And this predicate is going to allow us to determine whether or not, for example, we're flicking upward or downward with the rotor. And that is what we're going to test for inside of this closure so we can perform specific logic accordingly. Now, so what we'll do here is we'll say predicate. And then this closure is going to return a UI accessibility custom rotor item result. There we go. All right, so let's go over what we've done so far. So right now we have a constant rotor, and this rotor is going to be of type UI Accessibility Custom Rotor. We're passing it a name depending on the category. So if the category that we pass in to create rotor is National Park, then the rotor name will be National Parks. If the category that we've passed in is not National Parks and is Monument instead, the name will be Monuments. Then we're passing it a closure with a weak reference to self, and this closure takes in a predicate, which is, I believe, of type UI Accessibility Custom Rotor Search Predicate. Now, don't quote me on the type. We'll take a look at that in a moment. But then this closure will return a UI Accessibility Custom Rotor Item Result, which this type, now that I think about it, it's supposed to be optional. This type, it will basically tell the assistive technology which UI component it should focus on when the rotor action has been performed. So when you flick up, it needs to know what UI element, which accessibility element it needs to focus on. And same thing goes for if we flick down. It needs to know what accessibility element the assistive technology needs to focus on. And that's where the UI Accessibility Custom Rotor Item Result comes in. And we'll cover that once we actually get to the point where we need to return that. But underneath our rotor constant, we need to return our rotor, like that. All right. So what we'll do is in here, we need to determine whether or not we're flicking up or down. So we'll say let is flick up equals predicate right. So this is our type. I'm going to let's see, we want characters here. It is a UI accessibility custom rotor. Yep, search predicate. Yep, UI accessibility custom rotor search predicate. I was correct in the type. So that's what that is. So what we want to get from our predicate is predicate dot search direction equals dot previous, right? So if you are unfamiliar with how the accessibility rotor works in iOS, and in Mac Catalyst, for that matter, basically how the rotor works is when you rotate your fingers on the screen or your trackpad or whatever the case might be, like a physical dial, and you go to your rotor. When you flick up, that goes to the previous element that is focusable. When you flick down, then that will be the next element that needs to be focused. All right, so that's why for is flick up, we're testing to see if if we're going backward, not forward. All right. So now that we have this, the next thing that we need to do is we need to test to see whether or not we're flicking up. So if is flick up. So if we're flicking up, do this. Else, do this. All right. Now, if we want to go to the previous item, there's another thing that we need to do here, and that is we need to determine what the category of our rotor is and perform logic based on that. So what we can do is we can get the category that's passed in by saying let is national parks is equal to category is equal to dot national park. So now that we have a constant that's determining whether or not the category is for national parks, we can move on. So if is national parks, otherwise do that. All right. So now that we have this, I have a couple variables up at the top of my view controller. Let's go ahead and take a look at those real quick. At the top of our view controller, I have park index equals 0 and monument index equals 0. These are the variables we're going to use to keep track of which park or which monument we have already focused on, so then we can determine which we need to focus on next, depending on our flick direction. And then we have two computed properties for getting the different indexes for the parks and the different indexes for the monuments, each returning their own integer arrays. So that way we're not treading on things we shouldn't be treading on, right? So with that, we can go back to our create rotor method. All right. So, if we're flicking upward, and the category is national parks, we need to decrease the value of the park index if and only if it's greater than 0. So if park index is greater than 0, park index minus equals 1. All right. Otherwise, keep it the same. All right, so next, after that, we need to determine what to do if the category is not national parks, which if it's not a national park, right, then we can say if monument index is greater than 0, monument index minus equals 1. Like that. Pretty simple so far. Now, what we need to do here, okay, so now that we've done our logic for flicking upward, let's do flicking downwards. I want to make sure that we're doing this right. All right, so now if we haven't flicked up but we flicked down, we want to increase the values. So if is national parks otherwise, we'll do this. So if it's national parks, we'll say if park index is less than parks indexes dot count minus 1, then we'll say park index plus equals 1. Otherwise, don't do anything. Else we know that it's a monument. So if monument index is less than monument indexes, monuments indexes dot count -1, then we want monument index plus equals 1, like that. All right, so now that we have all of our logic complete, we're testing if we're flicking up or down, and then we are determining if the category is national parks or if it is monuments for both increment and decrement cases. Now, of course, I should mention that there are better ways of doing it, but I want you to see the logic happening here. Okay? So now that we've done this, what we can do if we're flicking upward and if it's a national park, what we'll do is after we have incremented our value, we will return UI accessibility custom rotor item result. And this will take in a target element and target range. Now, the target range is for if you want to go through some text with a custom rotor, but we're not going to do that, so that parameter is going to be nil. But the first parameter, target element, is going to be the specific element that we want to focus on. And what we're going to do here is we are going to retrieve the index. We're going to retrieve the next index that we want to of our cell to focus on. So let park index we'll just say park equals park's indexes at the park index. And then we'll say let cell equals locations dot cell for row at index path with a row and a section. So the row is going to be park, and then section is going to be 0 because we want the only one section that we have. And I'm going to force unwrap this because we know it exists. And then we'll pass cell as the first argument, and nil as the second. But we're not done yet. We've gone and returned out what we need to return for this one particular case, but we need to return something for every case. All right. So what we'll do here we need to do the same thing. So let monument equals monument indexes at the monument index, and then let cell equals locations dot cell for row at index path at our row, and this row is going to be monument and 0. And we'll force unwrap it there. And then we will return a UI accessibility custom rotor item result. The target element is going to be cell and nil for the second argument. All right, so now we'll do the same thing again, but this time it's going to go the other way around, obviously. So we'll say let park is equal to park's indexes at park index. Let cell equals locations dot cell for row at index path with a row and a column of park and 0. Like that. Go ahead and force unwrap it again because we know that it exists. If you don't know that it exists, make sure that you're not force unwrapping it. Make sure that you are unwrapping it in a safe way. But because we know it exists in this case, it's not a huge deal to force unwrap it. Then we're going to return another UI accessibility custom rotor item result. This is going to take in, again, a target element of cell and a UI text range of nil. And then, finally, we will say let monument equals monument indexes at monument index. Let cell equals locations dot cell for row at index path with a row and a column. The column is going to be the monument. And the section, again, is going to be 0. Go ahead and force unwrap that because, again, we know the cell exists. And then we, again, return a UIAccessibilityCustomRotorItemResult with a target element of cell and UI text range of nil. All right. All right, so now you can see we're getting some errors here because we need to use self, and we can resolve this by going to the top of our closure here. All right, so above all of this, what we'll do is we'll say guard let self equal self, else we will return nil. And now we can go through all of these errors and fix them. Because now that we've unwrapped self from its weak reference, so if self dot self self.park indexes, self again, and then where we have monument index, we'll do self again. And there we go, self let monument equals self.monuments indexes, and then monument index should be self.monument index. And then again here, we'll put, we need to sprinkle self everywhere in here. So self, self, let self, self, we're gonna again sprinkle self here. Again. Do it there as well. Okay, let's All right, there we go. Now that we've sprinkled self everywhere and we've done all of the conditions, we've made sure that we return something wherever we need to return something, we are good to go. So let's go ahead and we can go to our configure custom rotors method. Here we can say let parks rotor equals create rotor dot national park, let monuments rotor equals create rotor dot monument. And now we need to actually assign these UI accessibility custom rotors to an array of accessibility custom rotors on our table view. So locations dot accessibility custom rotors equals parks rotor, monuments rotor, like that. Save it, run it. Let's run the app, and we have a build failure. So let's see what we did wrong. Okay. Cannot assign. Okay, so we have an issue here. Oh, okay, I see. So we need to wrap that in square brackets here. All right, save that, run it, and now we have a successful build. So let's go ahead now and go into our list of locations. So in our table, now on macOS, like I mentioned in the previous video, because I'm on Mac Catalyst here, I'm going to hold down Command, Option, Control, and then use the left and right arrow keys to cycle through our rotors. We have national parks and monuments. Let's go national parks. Yosemite National Park, Grand Canyon National Park, Acadia National Park, and we try to go past Acadia National Park, and it doesn't work. It'll just return Acadia National Park every time we try to go past it because of the fact that we don't increment our value, our index after this particular one. We can go back up. So Grand Canyon National Park, Yosemite National Park, Yellowstone National Park, and after Yellowstone, there's nothing before it. So we can't go past index 0, which we prevented in our if statements. Now, inside of monuments, we're on Statue of Liberty to start with. Then we go to Washington Monument. Then we go to Lincoln Memorial. Then we go to Mount Rushmore. And we can't go past Mount Rushmore. We can go back up to the previous item. which is the Lincoln Memorial, then the Washington Monument, then the Statue of Liberty. And we can't go past the Statue of Liberty because when we reach Statue of Liberty, the monument index is 0 and we can't go past 0. All right, so that is how we can create custom accessibility rotors in UIKit. However, I want to go back over with you what we did because I know it might be slightly confusing and that's okay. So let's go ahead. Let's go down to our private method here. So private func create rotor, and we're passing it a category. So we want to create our rotor based on the category. Now, if we had more than 2 categories, I probably would have used a switch statement. However, because we only have 2, it's fine. You could improve the code's readability with a switch statement. I urge you to improve it. Because again, I just want to show you the logic here. This is not, by any stretch of the imagination, the most efficient way of creating rotors in a singular method based on the value of an enum. But again, it is sort of the educational way of doing it. All right, so inside of this method, we're creating a rotor of type UIAccessibilityCustomRotor. We are setting its name parameter to national parks or monuments based on that category. And then we're passing it a closure, and this closure needs a weak reference to self, which makes self optional here. And then this closure also takes in a predicate, a UI accessibility custom rotor search predicate. And this closure will return a UI accessibility custom rotor item result, which will tell the assistive technology what element it needs to focus on after the next item or previous item gestures with the rotor. All right. The first thing that we do inside of this closure is we are unwrapping self. We're making sure that self is not optional. If it is optional, upon entering this closure, we want to return nil. We don't want anything to happen. We don't want the app to crash. We just don't want anything to happen. So we return nil because the return of UI accessibility custom rotor item result is optional. So we can return nil. The next thing that we're doing is we are creating a Boolean constant to determine whether or not we are flicking upward or downward with our next or previous item gesture of our rotor using our predicate object. The next thing that we're doing is we're creating another Boolean constant to determine the category. We want to determine if the category is a national park or not, right? So if it's national parks category, do this. If it's not, do something else. All right. The next thing that we're doing is we're creating an if-else construct. The outermost if statement here is for determining which direction we're flicking. So, if we're flicking up, then we want to do the following. We want to test if the category is national parks. If it is, then we want to determine if the if the park index is greater than 0. If it is, we want to decrement that park index by 1 to go to the previous item. Then we retrieve the specific cell using the park indexes and all of that. And then we return a UIAccessibilityCustomRotorItemResult object with its target element being the cell that we just retrieved from our table view. So then VoiceOver or whatever assistive technology is being used will focus on that cell. All right. Now, if the category is not a national park, so if it's a monument, we are determining if the monument index is greater than 0, then we want to decrease the monument index by 1. And then the next thing that we want to do is we want to, again, get the specific cell in our table based on the monument index. And then have our assistive technology focus on that cell we just retrieved. Now, if we're flicking downward, we want to do the following. We want to test the category again. So if the category is a national park, national parks, then we want to test for whether or not our park index is less than however many parks there are, minus 1. So if we're already at the maximum index, so if we're not at the maximum index yet, rather, I should say, we want to increment that index. Then, much like we have previously, we need to get the specific table view cell based on that index and return that to our assistive technology so it knows what cell to focus on. If the category is not national parks, so if it's a monument, we need to determine if the monument index isn't quite the maximum index yet. So if it's less than the maximum index, we want to increase that monument index. Then, after that, we retrieve the necessary UI table view cell, and then we return that cell to our assistive technology as our UIAccessibilityCustomRotorItemResult target element with the range set to nil like we have in every other return case. Now, with that is all. That's all the work we did here. And so, really, that just about does it. That in this video, we covered how to create those rotors, how to assign the rotors to a view, and we went back over what we did in review. Again, you can clean up this code pretty easily. It's not the cleanest, and it's not the most effective way of doing it, but again, this is just for learning purposes. All right, thank you all so very much for watching. I know this was a bit of a long one, but as I mentioned, Rotors in UIKit is a little bit more involved. Thank you all for thank you all for watching. Make sure you follow me on Twitter /X or whatever you want to call it for more stuff from me. Also, make sure you leave a like on the video, leave a comment. Let me know like what kind of videos you want to see in the future, and we'll see you in the next video.